Hi everyone, this is Shruti here and I'm going to cover the very basics of Weka today. What is Weka and what does it do? Weka is a collection of machine learning algorithms which help us perform data mining tasks. It helps us pick the best the best classifier for a given data set. So let's move to Weka, and this is a GUI based interface, and it's very useful for the beginners. When you open GUI chooser, you have to click on Explorer and this dashboard opens. Here you can, through open file, you can pick the data set you want to. I have chosen here diabetes.arff data set. On opening, you see the list of attributes. Class is the target variable or the dependent attribute, and the others are independent attributes. On selecting every attribute here, you can see that on the right hand side you see the classes for each attribute, and also above you see the type of the data type, numeric or nominal. The class is nominal out here. There are no missing values for any of these the attributes. For more, you can click on the edit button and actually see the data set. Here you are also free to make changes to your data set if you want to. See numeric and then nominal, and the class which is in bold is the targeted attribute. So here you can make changes, though it is not recommended that you do so. Apart from that, on this dashboard, on the preprocesses, under preprocesses tab, you can see visualize all, where you can actually visualize all the attributes together or individually through the pull down button. The next is, apart from open file, you can open the URL or open the DB or generate your own data. Then others, there are also filters available here according to what is your need. You can filter your data set, but I'm not going to do that here. The next is the classify tab, which is the most important tab, and all algorithms are available here. The classifier I'm going to pick now is decision trees. Decision trees has J48 random forest, and I'm going to pick J48. Now when here, apart from that, there are these options: cross validation folds, which has more accuracy, and then percentage space 66%. 2/3 of the data goes to training set, 1/3 goes to data set. Select the target variable, click on start. You get your output here, classify output. This is the model, the prune tree model. Number of leaves 20, size of the tree 39. Time 0.01 seconds, which is fairly good for a small data set. Your 76% of instances correctly identified. Incorrectly identified 23%. The accuracy here is 76%, which is okay. Good. Apart from that is a confusion matrix here, which is important. The instances correctly identified for tested negative is 152 and wrongly predicted is 26. Your tested positive correctly identified are 47. Then from here you can also, what you can do is you can change the confidence factor. The confidence factor, when it increases, the accuracy will decrease. Here you can see that the accuracy has decreased from 76% to 75% because there will be lesser pruning. The number of leaves has increased to 22, which was previously 20. Apart from that, I can choose another function, another algorithm or a classifier that can be multi-layer perceptron. This is actually neural networks, and I'll stick to this. And what I get is the model for classifier model for neural networks with the weights and nodes given. Then here what you see is 74% accuracy, which is fairly good again, but it's less as compared to the decision tree. Here 152 rightly identified, 47 rightly identified, here 138 and 56, which is lesser than the decision tree. Now this depends on every data set that you pick. It's not necessary that it will be the same relation with every data set that you pick. Apart from that, visualize tool does scatter plots in 2D, and you can play with the jitter option more for more elaborate data points. Apart from this, what you can see is the decision tree, visualization tree, fit to screen, and this would be the decision tree. Apart from this, you can also check for the visualization tree later on for the confidence factor which was increased. There would be a difference and the tree would be even more bigger. That's it.